Shall we? What is the question? A square in xy plane and the electric field is given as 2I Newton per Coulomb. So find the flux passing through it. First and foremost thing you have to do is find out the area vector. Since it is in xy plane, what is area vector, ma? Area vector is given by what? Magnitude is a square and its direction is given by either minus k or plus k. So what is E also you know? Phi is given by E dot k. Here you need not find out the theta also. Directly you can use the dot product. 2I dot a square k. We know that I dot k is 0. So the flux passing through is 0. Clear everyone? If this is clear, then I will move to the closed surface, like Q. Stop me if I am going too fast, okay? If you want to copy or something, just stop me. Okay, now, so consider the cube. It is a closed surface, right? See, here when I draw, it won't be that perfect like cube here and there. At least okay this time. Now, see, throughout this chapter, whenever we consider cube, we will follow one convention that I am telling you. Okay, this is left side 1. Okay, up 2. Then right side 3, then down 4. 6 faces, right? A cube has, down is 4. Then front is 5, back is 6. Just remember that, okay? 6 surfaces, 6 thing we will give it. Now with example, we will see that. Now you just, if the electric field is constant, there are two ways possible, okay? Two conditions, two cases here. If the electric field is constant and is along positive x direction. Say for example, let electric field is again 2I Newton per Coulomb only we are taking. Okay, and the cube of side A we are taking. Now, how many phases? Each phase we have to find out the flux, correct? So how will you do that? Each phase you take. Before that first step, what did I say? You have to find the area vector. For the phase 1, remember that it is a closed surface, only outward area vector is possible, correct? So where will be the area vector? It will be along the negative x-axis, this way. And for the phase 2, it will be along the positive y-axis. For 3, it is positive x-axis. For 4, it is negative y-axis. 5, it will be positive z-axis. 6, it will be negative z-axis. Just you draw the area vector. Now, is that clear? And where is the electric vector? See, all these things I will write it. First phase, everything. So 1, if I write it, what is the area vector definition? Area vector, it is a square only because it is a cube of side A. Magnitude will always remain a square. What is the direction of area vector for 1? It is minus I. Okay. For second one, what is the area vector? A square, but it is upward, so positive J. For third one, area vector will be what? A square, it is positive I cap. Fourth one will be nothing but, what is it now? A square minus B. And fifth phase, here it is phases, okay? Fifth one, it will be A square and it will be positive K. And sixth one will be equal to A square minus K. The reason why I am writing everything is, through the calculation you will come to know, okay? Even if you don't understand it, that is explanatory part. You can use the formula way, okay? So what is electric flux? Electric flux is given by E dot E. Electric flux is along x-axis, right? So you should try to understand this theoretically also. when the electric field is given in this direction. So all these, consider this 2, 4, 5, 6. In all these cases, what happens, ma? The area vector is perpendicular to the electric field because electric field is constant along x-axis. But here in all the phases 2, 4, 5, 6, area vector is perpendicular to the electric field. So phi you can directly write 0. But no, ma'am, I want it in true formula. If you say, then also it is fine. Phi is given by E dot A. So for the first surface, I1 is given by what? It is E is 2I dot. What is the first phase? It is A square into minus I. Okay? So phi1 will be minus 2A square. So what is phi2, ma? Phi2 is E dot A, right? So it is E, that is nothing but 2I dot A square into J. What is I dot J? I dot J is 0. So we can write phi2 is 0. Hope you are following it. Similarly, what is phi3? Phi3 is 2I dot A square into positive I cap. It will be 2A square. But phi4, how much it will be? It is nothing but phi4 is, again I will do that, no issues. A square into fourth one is minus J. I dot minus J is also 0. And phi will be equal to 2I dot A square into, for the fifth one it is K. I dot K is 0. For the sixth one, it is phi6 will be 2I into A square minus K. Again, it will be 0. What is the total electric flux over this? The net electric flux of this system is what? It is given by phi1. It is a scalar quantity. So, simple addition is enough. So, how much? It is phi1 and phi2 will be, phi3 will be there. All others are 0. It is minus 2A square plus 2A square, which is nothing but 0. Is it clear? For your understanding, I have done this much. But in exam, you should not write all these things. And especially MCQ, you should just remember that if E is constant, then for a closed surface, I is 0. Total electric flux enclosed in a closed surface placed in an uniform electric field will be 0. In simple words, I have written. Is it clear now? This is the essence of this. If you remember this, it will be very easy. But it is not true when the electric field is not, it is not a constant. If electric field is variable, I won't do all these things, you know. 2, 4, 5, 6, it will be 0. But remember this point alone. At this point, what is the axis? 0, 0, 0 coordinates. And what is the side of the cube? Here it will be A, 0, 0. Yes or no? For this phase, only what is the phases in consideration? Only 3 and 1. For 1, what is the coordinate of x, ma? It is 0, 0, 0. Right? So what is the flux associated with it? Before that, let me say electric field is given by 2xi. It is not a constant. Since x is variable, electric field is also variable. Is it clear or no? When you put x values, the electric field value will increase along the x-axis because it is given positive I. Forgot to mention this. Now is that clear? Here electric field is variable and it is increasing along the x-axis, positive x-axis. Now what is the coordinate if I put 0? For the first phase, what is the x value? X value will be 0. Phase 1, x value will be 0. So what is the value of electric field? Electric field itself 0. So what is phi1? Phi1 will be 0. Right. For phase 3, what is the x value? A. So what is the value of electric field? 2ai. And what is the area vector? Already we know that A square I cap. So what is electric flux? It is 2a cube. Newton meter square per coulomb. Is it clear or confusing? Just let me know. For all other phases, 2, 4, 5, 6, electric flux is 0 because E is perpendicular to area vector. But in this case, if electric field is constant, then we can say that the closed surface, the electric flux is 0. But here in the given condition, electric flux is electric field is variable. So the flux will also be varying from one point to another. It won't be 0. Is it clear or no?
Yes, ma'am.
All of you? Only one more surface I will consider, so that if you are clear with electric flux, then we can move to the Gauss law and application. The next consideration is, instead of cube, you can consider cylinder. Cylinder is any axis they can give. I am just discussing only x-axis. Electric field along x-axis I have discussed. If electric field along y-axis, then the cube faces will vary. Okay, keep that in mind. It is just a simple example. It will vary according to the given condition. You should know the procedure or the steps so that you can do it on your own. So now in this condition, where is the electric field given? It is along the x-axis. And if it is constant, then what I can say, already you know that electric flux over a closed surface is 0, right? So you can write it directly. Okay. But if electric field is variable, then you have to, at this point, what is the value? Electric field is 0. For this phase, electric field will be, you have to find out the value. But here, why I have taken this example is, for cylinder, the procedure is same for all the closed surfaces. But for cylinder, 2 flat surfaces, 1 curved surface. When the electric field is along x-axis, this curved surface, here the area vector will be outward, and for this surface, area vector will be outward. Okay, and here it will be this way. What is the direction of electric field and area vector? Electric field is along x-axis, area vector is along y-axis. So for curved surface, the contribution of flux to the curved surface will be 0. Only 2 flat surfaces will contribute them. So the net flux can be given by, if this is area 1, this is area 2, and area 3, phi 3 will be 0. It will be nothing but phi 1 plus phi 2 with a sign. It is not vector, but inward flux, outward flux is there. No? So because of that. So I think I explained all these flux. Only one thing is,